Welcome everybody to the RxJS workshop. My name is Tracy and I'm an instructor with the Angular work team. Here at the workshop, every other Tuesday, we have an RxJS coding challenge. Running in my browser, I have this week's coding challenge, the pangram challenge. A pangram is a sentence or phrase that contains at least one occurrence of every letter in the alphabet. And when this UI loads, the text area control loads with a pangram. Margie wove and quilted 6 dozen beautiful plaid jacket and hat sets. That sentence in the text area contains at least one occurrence of every letter in the alphabet. And in the upper right-hand corner above the text area, we have a label which is displayed whenever the sentence or phrase in the text area contains a pangram. Now, this sentence contains only one letter Y. And if I remove that letter Y, notice the label changes to lipogram. And a lipogram is a sentence or phrase that contains at least one occurrence of every letter in the alphabet, except for one. So when I removed the single letter Y from the sentence, the pangram changed to a lipogram because now the sentence contains every letter in the alphabet except for the single letter Y. Now, if you take a look at the letter counts display area, we see a dashboard, and the dashboard consists of the number of occurrences of things, the total number of occurrences of things. So first we have the total number of alphas, which is the total number of all of the letters in the sentence or phrase. Then we have the total number of vowels, that is A, E, I, O, and U. And lastly, we have the total number of consonants, which are all of the alpha except for the vowels. Below that, we have displays, which show us the total number of occurrences of each letter as it appears in our sentence or phrase. And you notice that each of the letter displays with their counts, they're all formatted in the same way, except for the letters A and the letter Y. Now, the letter Y is highlighted in brown because it is the letter that makes the sentence or phrase a lipogram. It's the single letter that has a count of 0. The letter A, on the other hand, its count is highlighted in green. And the reason for that is the letter A contains the most occurrences in the sentence or phrase. Now, because a lipogram should have only one character whose count is 0, we should only ever see one character display where the letter is highlighted in brown. However, we can have multiple letters that have the same highest. So for instance, if the letter B had a count of 7, we'd also see its count in the color green. So currently the sentence is a lipogram because it contains no occurrences of the letter Y. But if I type in once again the letter Y, the sentence is changed from a lipogram to a pangram. Now, our letter displays have a few interesting characteristics. And before I show them to you, I'm going to once again remove the letter Y from the sentence and change the sentence back into a lipogram. If we hover over any one of the letter displays, notice how the letter display jumps off the page. And that's true for any letter display that has a count greater than 0. However, if we hover over the letter Y, which has a count of 0 and is indeed the letter that makes our sentence a lipogram, notice this character, the character Y, does not have a hover state. When we hover over it, it does not jump off the page. So that's one characteristic of the letter displays. Another characteristic is if we click on a letter display that has a count greater than 0, notice what occurs. When I clicked on the letter U, its border changed to the color orange. And notice in the text area, all of the occurrences of U have highlighted in yellow. The letter U has a count of 3, and notice there are 3 highlighted U's in the text area. Something to note about the text area when it's in this highlighted state, that is, it has characters that are highlighted in yellow. When it's in this highlighted state, the text area is not changeable. That is, I can copy the word plaid, but I can't paste it. There is no paste or cut option in the context menu. And that's because when the text area is in a highlighted state, it is not editable. If I click on the letter display for U again, notice the orange border goes away and the text area no longer has the highlighted characters, and now it returns to an editable state, meaning I can cut and paste characters in the text area. Now, if I go to a letter display where the character count is 0, notice this character is not clickable. And that's to be expected because there are no occurrences of this letter in the sentence. So those are some of the characteristics of the letter displays. When their counts are greater than 0, when hovered over, they lift off the page in sort of a 3D representation. And when the letter display's count is greater than 0, the letter display itself is clickable, and clicking the letter display highlights the occurrences of that letter in the sentence. Clicking again removes the border as well as removes the highlighting of the occurrences of the letter. And for those characters whose count is 0, their letter displays are not hoverable and they are not clickable. Also note that when we click on a letter display and highlight its occurrences, and we click on another letter display, the occurrences of the previously clicked letter are unhighlighted and the occurrences of the newly clicked letter are highlighted. But if a highlighted character's letter display is clicked again, then the highlighting and the orange border of that letter display are both removed. So those are all the things to note about the behaviors of these letter displays. Now, the last couple of capabilities of our pangram UI is that when the text area is in an editable state, we can type anything that we wish to assess the character counts of, as well as whether or not the sentence or phrase that we enter is a lipogram or pangram or neither. So if I highlight the current sentence and I type "the quick brown fox jumps over the lazy dog," this is a very well-known pangram, which of course contains at least one occurrence of every letter in the alphabet. And if I remove the letter G in dog, then the sentence becomes a lipogram, where G is the only character that has a character count of 0. So we can enter sentences manually, sentences and phrases manually. Or we have this generate a sentence button, which will generate a random sentence consisting of Latin words. And with each generation of a sentence using this button, the pangram lipogram label will update accordingly, as well as all of the letter counts. So I'll click on the generate a sentence button, and notice all of the letter counts have updated, as well as the label in the upper right hand corner has been removed. And that's because the newly generated sentence is neither a pangram or a lipogram. It's not a lipogram because there are a number of characters which have a count of 0. The letters J, K, W, X, and Z all have a count of 0. So therefore, this newly generated sentence is neither a pangram or a lipogram. And we can generate and regenerate a sentence clicking on this button. And I'll click it a few times. And notice there are times when the randomly generated sentence is a lipogram. So in this case, there's no letter Z in this sentence. And if I continually generate new sentences, new randomly generated sentences, there are occurrences where the newly generated sentence is a lipogram or a pangram or neither. So I'll just click on this, and we now have a sentence which is a pangram. All of the letters in the alphabet are represented in that sentence. Now I'll try to click a couple of times to show you when multiple letters have the highest count. Notice in this instance, the randomly generated sentence is neither a pangram or a lipogram, but there are 2 letters with the highest count of 10. That's the letter A and the letter N. So these are all of the characteristics of our pangram user interface. And you may be wondering why it is that I came up with such a user interface. And essentially, it's because this kind of interface represents a dashboard, and often front-end developers, particularly RxJS developers, are confronted with the requirement of creating a user interface that's a dashboard that contains a number of different pieces of data that are aggregates. And we're also often tasked with making our dashboards interactive, that is hovering over user controls and enabling and disabling and highlighting according to the state of data. And this is where the RxJS library and observables really shines, because it allows us to do this sort of dashboarding and enabling and disabling and highlighting. It allows us to do all of this user interface manipulation via observables. So now that you see how our user interface is supposed to work, let's take a look at the actual coding challenge itself. Before we take a look at the starting code for our coding challenge, there is something that I neglected to mention about the generate a sentence button, and that is the code behind that button. In actuality, a real sentence is not being generated. What's actually happening is there is a collection, an array of Latin words, and each time this button is clicked, a random number of those words are pulled from the array and concatenated with spaces in between. So I just wanted to bring that to your attention for those of you who are truly adept at Latin. I wanted to make clear that these are not real sentences in Latin, as far as I know. So now let's take a look at the code. The first thing to note about the coding challenge is that it is an Angular 18 project. And let's first take a look at the template file, the HTML file. So notice there is an async pipe into an observable called stats observable, stats $. And it is the only observable that our template is using, that it's subscribing to. And this observable contains all of the values that we need to display in our user interface. And stats observable contains a number of properties, including the highlighted sentence property, the sentence stats property. If we scroll further down, we also see the letter stats property. And part of your challenge is to create observables that will set each of these properties on the stats observable. One thing to note about the text area that we're displaying, the text area is actually two separate HTML elements. It's a text area that's editable when it's in a state that has no highlighted characters, that yellow highlighting of a clicked character. When it's in that state, the text area is being displayed. We have an ng if to display that text area. When the sentence within the area is in a highlighted state, that is, there are highlighted characters in yellow, then there is a div element that is made visible via an ng if. And of course, a div element is not editable. Now, taking a look at the component, notice we have an interface called VM, which contains all of the properties that you need to set within the stats observable. The VM interface has 4 properties, as we saw in the template file. It's got a sentence stats property, a letter stats property, a selected car or selected care property, and a highlighted sentence property. Below our VM interface, we have a constant, which is an object that is of type VM. So this is our default state for our user interface. Moving further down in the code, we see that the stats $sign observable is set to an instance of the VM default constant. And we simply use the of operator to turn that constant into an observable. And at the end of this file, we have 3 public methods: letter clicked, input changed, and generate new sentence. And each of these methods is calling a method on the service for this component. And that service is called app service. So let's take a look at the app service file. And notice there is very little code in our app service. However, we do have the 3 public methods that are being called in the component file. And this is actually your challenge, to create the observables and observable properties that will make the user interface work in all of the ways that I demoed to you in the beginning of this video. Now, also in this service, are some interfaces that will help you along the way. For instance, there's a sentence stats interface and a letter stats interface. The sentence stats interface contains properties such as sentence, which is the actual sentence that's entered into the text area or that's generated, the total alpha, the total alphas, which is the total number of letters in the sentence, the count of letters in the sentence, the total vowels property are the total number of vowels in the sentence, and of course, the total consonants are the total number of consonants in the sentence. There are two Boolean values, is pangram, is lipogram, which should be set when the sentence is either a pangram or a lipogram. And there's also a lipogram letter property, which is the single letter within the sentence. If the sentence is a lipogram, it's that single letter whose count is 0. There's also a letters with highest count array, and that is an array of the characters that have the highest count. So if it's a single letter, then there will only be one letter in the array. But as I showed you in the demo, you can have multiple letters that have the same highest count value. And each of those letters should be set into this property, letters with highest count. The letter count property is actually an object, and it's an object where the key is the given letter. So we'll have keys of A, B, C, D, and so on. And the value is the count of the appearance of that letter in the sentence. And then we have the letter stats interface, which has 3 properties. The char property, which is, of course, the given character or letter. The count property, which is, of course, the number of occurrences of that letter within the sentence. And a Boolean value, which has highest count, which if this particular letter appears in the sentence stats letters with highest count array, then the value of has highest count should be true. Otherwise, it should be false. So that's the starting point of the code. And I've also created a utils file that consists of all of the functions, the ad hoc functions, and array of Latin words. All of those things are in this utils file, and you can take a look at the code, and all of this code is yours to use as is or to modify in any way that you see fit to complete the coding challenge. Now, one more thing about the service and the coding challenge itself is that you can use any RxJS operators or features that you see fit to complete the challenge. And that means you can use subjects along with any combination of operators to create observables that will make the user interface work as you saw in the demo. But I'm also going to give you a few bonus challenges in this coding challenge. One being that all of the properties on this app service should be observables. We shouldn't have any instance variables, that is, properties that are just values. All of the properties on the app service should be observables. Whether those observables are derived from other observables or they are subjects, that's up to you. But every property, every public property on this service should be an observable. The second bonus challenge that I'm going to present you with is the use of 3 operators: the combineLatest operator, the scan operator, and the withLatestFrom operator. So you get bonus points if you use all three of those operators in your coding. So in summary, your challenge is to create any number of observable properties on this app service to make the user interface work as we saw in the demo. And of course, these observable properties in the service should be called by the component, namely the stats observable. So you should really replace the of operator with the observables that come from the app service. Again, the app service should consist only of observables, not of instance variables. And as a bonus challenge, you can use the combineLatest, scan, and withLatestFrom operators anywhere within your coding. And those operators can exist either on the service or on this component file. It's up to you where you code them. And of course, your starting point is all of the things that I filled in to the template file, the component file, and the service file to this point, as well as the utils file of functions. So that's your coding challenge. Here is the Git repo that contains the starting version of our coding challenge. And this is also the location where in 2 weeks' time, I'll post my version of the solution to this coding challenge. So every other Tuesday, we'll discuss the solution to the previous coding challenge, and I'll also present you with a new coding challenge. Until then, I'll be posting videos to the channel that discuss and demonstrate all things RxJS. Please do subscribe to the channel and become an integral member of the RxJS workshop.